Bismillahirrahmanirrahim. Assalamu alaikum students. This is your chemistry teacher Farzana Nazir. Today we are going to continue our chapter 7 that is related to electrochemistry. Today we are going to discuss electrolytic cells, applications of electrolytic cells. We are going to discuss electrochemical industries for the manufacture of sodium metal from fused sodium chloride and manufacture of sodium hydroxide from brine. After going through today's lesson, students will be able to explain the electrolytic cell. They can easily list possible uses of electrolytic cell. They can easily explain the manufacturing of sodium metal and sodium hydroxide from fused and molten sodium chloride. Now let us start our today's lesson, electrolytic cells. An electrochemical cell in which electrical energy is used to drive a chemical reaction is called an electrolytic cell. Components of electrolytic cell. An electrolytic cell consists of a vessel containing an electrolyte, two inert electrodes, and a battery. When the circuit is complete, the electrons move from anode to cathode in the outer circuit. In the solution, cations move toward cathode and anions move toward anode. At cathode, anions oxidize by losing electron. At cathode, cations reduce by gaining electrons. This means oxidation occurs at anode and reduction at cathode. Now let us discuss electrolysis of fused NaCl in detail. Electrolysis is the decomposition of a compound in the solution or in the molten state brought about by the passage of an electric current through it. In electrolytic cell, the substance in the molten state which conduct electricity is called electrolyte. In molten sodium chloride solution, sodium ions and chloride ions are freely moving. Two platinum electrodes can be used as electrodes. The electrode which is connected to the positive terminal of the battery is called anode, whereas the electrode which is connected to the negative end of the battery is called cathode. The apparatus is set up as shown in the figure. When electricity is passed through the molten sodium chloride solution, sodium ions move toward the cathode, which is a negative electrode, whereas chloride ions, which are anions, move toward the positive electrode. At cathode, sodium ions receive electrons from cathode and are discharged into sodium atom and deposit at cathode. Similarly, chlorine ions give off electrons at the anode and discharge into chlorine atoms. Chlorine atoms combine with each other to become chlorine molecule. Chlorine gas is evolved at anode. As a net result, we get sodium at cathode product and chlorine gas as anode product. Applications of electrolytic cell. Nelson cell is used for the commercial preparation of sodium hydroxide. It also produces chlorine and hydrogen gas as byproduct. Down cell is used for the commercial preparation of sodium metal. It produces chlorine gas as a byproduct. It is used for the purification of copper. Electrolytic cells are used to electroplate metal such as tin, silver, nickel, etc. on steel. Electrolytic cells are used for the commercial preparation of calcium and magnesium metals. It is used to produce aluminum metal commercially. Electrolytic cells are used to prepare anodized aluminum dye. Dyeing of anodized aluminum can produce metallic red, metallic blue, or other metallic colors on the metal surface. Electrochemical industries. Electricity is extensively consumed by the chemical processes industries. Electrochemical industries uses electricity to bring chemical changes and produce wide variety of substances. Such industries are called electrolytic industries. These industries produces substances that cannot be made economically in other ways. For example, aluminium, calcium carbide, sodium hydroxide, magnesium, and hydrogen. These industries also include electrolytic refining and electroplating industries. Electricity is also used to produce heat that produces high temperature required in the electrothermal chemical industries. Now, let us first discuss manufacturing of sodium metal from fused sodium chloride. In 1920s, American chemical engineer Jacques Down devised a cell to produce sodium and chlorine that were kept apart by a simple Einmeyer screen. The down cell has a central carbon anode and a cylindrical iron cathode. Neither of the electrodes take part in the reaction. Solid sodium chloride is poor conductor, so it is heated to melt it. The electrolyte is a mixture of sodium chloride ions and calcium chloride ions. The calcium chloride take no part in the reaction. It lowers the temperature needed to keep the electrolyte molten. At the anode surface, the power supply pulls the electron from the chloride ions and form the molecules of chlorine. Here is the half equation for oxidation of chlorine. At cathode, the electrons from power supply are forced onto most reactive cation, the sodium ions. Here is the half reaction for the reduction of sodium ions to liquid sodium metal. The ion measure screen allows the sodium and chloride ions to pass through it, but keeps the product apart. Since the liquid sodium is less dense than the electrolyte, the sodium floats up into the hooded structure as the reaction proceeds and is tapped off. Meanwhile, chlorine gas bubbles up from the anode into a separate vent. Here is the equation for overall reaction. Now, let us discuss the manufacturing of sodium hydroxide from molten sodium chloride, which takes place in down cell. Nelson cell or diaphragm cell is used in the production of caustic soda. A steel tank is used as cathode compartment. Perforated steel acts as cathode. Porous asbestos separates the anode and cathode compartments, which allow ions from the water pass to the cathode. Graphite anode kept in the anode compartment is filled with brine. Brine is a concentrated solution of sodium chloride. Steam passes through the cathode compartment. As a result of oxidation of chloride ions at anode, chlorine is liberated at anode. Electron pass to the cathode through outer circuit. Hydrogen ions from the water pass to the cathode. At cathode, hydrogen ions are reduced to hydrogen atom and form hydrogen molecule. Hydrogen gas escapes from the cathode. Sodium ions pass to the perforated steel cathode. Excess hydroxyl and sodium ions form caustic soda solution. The caustic soda solution runs off through the siphon. As the reaction in the Nelson cell continues, hydrogen gas is liberated at cathode, whereas chlorine at anode. Similarly, sodium hydroxide solution collects at the bottom where it is periodically removed. The NaCl is filtered and the solution of sodium hydroxide is further evaporated. Solid sodium hydroxide is produced as the final product. Now, let us have a review of what we have studied today. An electrochemical cell in which electrical energy is used to drive a chemical reaction is called an electrolytic cell. Electrochemical industries use electricity to bring chemical change and produce wide variety of substances. Such industries are called electrolytic industries. Manufacturing of sodium metal can be achieved by the electrolysis of sodium chloride in fused form in a down cell. Manufacturing of sodium hydroxide can be achieved by the electrolysis of molten sodium chloride, also known as brine, in a Nelson cell. Students, I hope you have enjoyed today's lesson and clearly understood the chemistry behind the electrolytic cell and how different chemicals are manufactured in different chemical industries. Now, here are some questions which are related to today's topic. Question number 1. Sketch an electrolytic cell for the electrolysis of fused KCl. In this question, you have to draw the diagram of electrolytic cell, label anode and cathode, and also show the direction of flow of current. Question number 2. Draw and label diagram of down cell and Nelson cell. Also write the reactions occurring at anode and cathode.